Chapter 9, Unit 4. Let's talk about a directional hypothesis and one-tail test. So here's an example. A researcher is expecting the level of alertness to be reduced on the morning after late-night reading. Therefore, the researcher predicts that the participants will have an average alertness scale lower than the mean for the general population, which is mean equals 50. The researcher tested a sample of 9 participants and obtained a mean score of 46 with SS equals 162. Test for significance using a one-tail test with alpha equal 0.05. Well, remember with directional hypotheses, you always do the research hypothesis first, so H1. And in this case, the researcher actually thinks that the average alertness score is going to be lower. So your research hypothesis would be H1, the mean is less than 50. And then you do your null hypothesis, which is the opposite of that, H sub O, mean is greater than or equal to 50. So you're going to use your degrees of freedom, which would, in this case, it's going to be 8 since n is equal to 9, and you're going to use alpha 0.05 and one tail to find t-crit in the tables. So here's how you would draw your picture. You think that it's going to be lower, therefore you're going to use the lower end of the graph and you're going to have only one tail. The critical value would be negative 1.86 from the tables. Next, you're going to do your calculations. So your sample variance would be S squared is equal to SS over N minus 1, and you would get 20.25. Then you could go and find your estimated standard error, which in this case would give you 1.5. And finally, you could find T. Put in the values for M and mu and the estimated standard error, and you should get negative 2.67. Put an X on the graph. And your result here, reject the null. You're in the rejection region. There is a significant treatment effect. How do you report these results? You say after reading from a light emitting screen at bedtime, alertness scores the next morning were significantly lower than would be expected if there were no effect. T of 8 is equal to negative 2.67. The probability is less than 0.05, and this is a one-tail test. So let's look at learning check problem 1. A sample is selected from a population with a mean of 50 and a treatment is administered to the sample. If the treatment is expected to increase scores and a t statistic is used for a one-tail hypothesis test, which of the following is the correct null hypothesis? Okay, well, let's think about it. The treatment is expected to increase scores. So your H1, which would be your research hypothesis, would be mean is greater than 50. But this is asking for the null hypothesis, which would be the opposite of that. So you should have picked A, mean is less than or equal to 50. Learning check problem 2. A researcher predicts that a treatment will increase scores. To test the treatment effect, a sample of 16 is selected from a population with a mean of 80, and the treatment is administered. After treatment, the sample mean is 78 with a variance of 16. If the researcher uses a one-tail test with alpha equal 0.05, what decisions should be made? Well, let's figure it out. Step 1 is always to write your hypothesis. In this case, the researcher believes that the treatment will increase scores, so the research hypothesis would be the mean is greater than 80. That means the null hypothesis would be less than or equal to 80. Step 2, if n is equal to 16, that means the degrees of freedom is 15. So for your first graph, let's test it with alpha equal 0.05, one tail, and you should get a critical value of 1.753. Then let's repeat that for alpha 0.01. So we're going to draw a second graph, and then using alpha 0.01, degrees of freedom 15, you're going to find a critical value of 2.602. So now let's calculate t. Well, first we have to know the estimated standard error, and we have everything we need because we know s squared, we know n. So you find an estimated standard error of 1. Next you can find t, and you should have found it to be negative 2. Put an x in both graphs. You're going to fail to reject the null. In either case, both the alpha 0.05 and the alpha 0.01 actually, the sample mean that they gave you of 78 is actually lower than the population mean of 80. So the hypothesis that they asked where the researcher predicts the treatment's going to increase scores, that should tell you right off the bat that it's not going to work because the mean is less than the population mean. So there's no way it's going to increase scores. So you would never be able to predict that the treatment would increase scores. So your answer would be B. You're going to fail to reject the null with 0.05 or 0.01 as your alpha level. Learning check problem 3. A researcher fails to reject the null hypothesis for the regular two-tailed test using alpha equal 0.05. If instead the researcher had used a directional one-tailed test with the same data and the same alpha level, what decision would be made? Well, if you look at A, B, and C, you can see the word definitely. Well, you don't know definitely anything. So your answer would be D. You might possibly reject the null hypothesis if the treatment effect is in the predicted direction.